The equation of a curve is such that dy by dx is equals to 3 upon square root of x minus x. Given that the curve passes through point 4, comma 6, find the equation of the curve. Okay. So we're given dy by dx. We will need to integrate it to get y, the equation of the curve. I'm rewriting the equation as 3x power negative half minus x. Now we're going to integrate this 3x power negative half minus x dx, and the left-hand side becomes y once you integrate it. So y equals 3x minus half plus 1 would be half, and we get a half over here. This I'm going to simplify as 6 because 3 upon half is 6. So there's a 6 here, minus x squared upon 2 and plus c. Remember the plus c, the constant of integration. Now we need to find the value of c, so we can substitute this given point 4, comma 6 in the equation of the curve. So that gives us 6 equals 6 times 4 times half would be 6 times 2, 12, minus 2 plus c. We have 10 here. C is equals to, no, hold on. This is 4 square is 18. I'm sorry. And 18 divided by 2 is going to be 4 square is 16. 16 divided by 2 is going to be 8. So this is a mistake. Minus 8 plus c, which gives us, this becomes 4. And then 6 minus 4 is 2. So c is equals to 2. So the equation of the curve is coming out to be y equals 6 x power half minus x squared over 2 plus 2. Okay, part 1 is done. Part 2 says the diagram shows another curve. Okay. So the diagram shows this curve, a cubic curve, and the curve has a maximum point at A and minimum point at B. So we know at maximum dy by dx equals to 0. Also at the minimum dy by dx equals to 0. Okay. The normal to the curve at C, 2, comma 2, meets the normal to the curve at D. Okay, so this is the normal to the curve at C, and this is the normal to the curve at B. That's just a vertical line. Okay, in the first part, we have to find coordinates of A and B. So we have to derivate the given curve and equate it to 0 because that's the stationary point. So dy by dx is going to be 3 is going to come down, 3x squared minus 2 is going to come down, minus 12x plus 9 equated to 0. So I'm going to divide both sides with 3. So x squared minus 4x plus 3 is equals to 0. I'm going to factorize this. X squared minus 3x minus x plus 3. Take x common. X minus 3. Take negative 1 common. X minus 3. So we have x minus 1. X minus 3 equals 0. That gives us x equals 1 and x equals 3. Okay. So we need the full coordinates. So A would be 1 comma something. B would be 3 comma 0 because it touches the x-axis. It's the x-intercept. So y is going to be 0. Okay. To find the y coordinate of A, we just substitute 1 here. And we get 1 cube minus 1, just 1 minus 6, which is minus 5, plus 9 is 4. So it's 1 comma 4. So we have the coordinates of A and B. This is 4. That's 1. And this is 3. Okay. Moving on. Now it's asking to find the equation of the normal at C. Okay. So for that, we will first need to find the gradient of the tangent, and then take its negative reciprocal to find the gradient of the normal. Okay, so let's first derivate the given curve. The curve is y equals x cubed minus 6x squared plus 9. So we already did dy by dx for that. It was 3x squared minus 12x plus 0. Now we're going to substitute uh, the value of x at c. But how do we find what is c? C is already known. Never mind, 2 comma 2. So let's substitute 2 here. So we get 3 times 2 squared minus 12 times 2. It's giving us minus 12. So the gradient of the tangent is coming out to be negative 12. Okay, shouldn't be negative 12. It should be negative 3. I probably messed up somewhere. Okay, I did not write, this was an x, I'm sorry, and there's a plus 9 with it. So when we add 9 to it, we do get negative 3. Okay, so the gradient is negative 3. So the gradient of the normal is going to be negative reciprocal of that, which is 1/3. And this is going to be y equals m. In fact, we should just use point slope form because they're not asking us to give the answer in the form of y is equals to mx plus c. So gradient is known 1/3 and the point c is known 2 comma 2. So the equation of the normal is going to be y minus y1 is equals to m x minus x1 in point slope form. And if you want to use y is equals to mx plus c, then you will be rearranging it. So it's going to be 1/3x and then negative 2/3 plus 2 gives 4/3. Okay. So that is the equation of the normal. So we have equation of this line. If I'm saying, yeah, y equals x, 1/3 x plus 4/3. All right, next part is find the area of the shaded region. Okay. Okay. So area of the shaded region is, this would be a trapezium. So find area of this full trapezium, and then from this trapezium, subtract the unshaded area. Subtract this, and we should get area of the shaded region. Okay, let's look at the trapezium first. So we need the trapezium area minus the area of integrating the curve within the limit. Okay, what are these limits? This starts from 2 and goes till 3. So 2 to 3 and x cubed minus 6x squared plus 9x. Okay. Now, how do we find area of the trapezium? This would be the height of the trapezium because of this right angle. Okay, that's going to be 1. And we need the parallel sides. This length is 2, we know with C. So this height is 2, or this length is 2. What about this other side? What is going to be height of this side? For that, we need the y coordinate of D. We already know the x coordinate of D, that's 3. So I'm going to substitute 3 here. 3 cubed minus 6 times 3 squared plus 9 times 3. That should be the height of the red line, which comes out to be sorry, this is a big fat blunder. Why would I substitute the coordinates of D in the curve? It's not even on the curve. D is on this line. So I need to substitute x is equals to 3 in the equation of the normal that we got earlier. Okay, so let's substitute 3 here. Y equals 1/3 times 3 plus 4/3. That's 7/3. So this height is going to be 7/3. So the area of the trapezium is going to be half times the height, which is 1, times sum of the parallel sides, which is 2 plus 7 over 3. And this comes out to be 7 by 3 plus 2 times half. I'm getting 13 by 6. So area of the trapezium is 13 by 6. From this, we subtract the result of the integration. Let's see what that would be. Okay, integrate the curve. We get x power 4 upon 4 minus 6x cube upon 3 plus 9x square upon 2 and substitute the limits 3 and 2. Okay, so let's do that. Let's substitute 3 first, then put a negative sign and put 3, substitute 2 then. Okay, so when I substituted 3, I got 27 over 4. When I substituted 2, I got 6. So now we get 13 over 6 minus, subtract these two fractions, you should get 3 upon 4. And then subtract these two fractions and you should get 17 upon 12 as the final answer.